While working on a test, you feel a Nerf dart hit you from above. Your masterful physics instincts tell you that the dart hit you with a velocity of 32 meters per second. You look up to see Mr. Mincheski in the ceiling with a Nerf gun. Mr. Mincheski fires another Nerf dart, and you intuitively know that it takes a full 4.75 seconds to hit you. What is the initial velocity of the Nerf dart? And what is the height of the ceiling, assuming your head is 0.75 meters off the ground? Now, I made a mistake in this one. That 4.75 seconds is actually going to cause our situation to look a little weird. So I'm going to do a video, first, this one, where I change this 4.75 to 2.75 seconds. And then in my next video, I'm going to go through and do it with 4.75, show you that it still works for any of you that have already done it and were maybe confused about it. So in this one, we're going to start out by listing our equations. S equals xi plus vit plus 1/2 at squared. And a is equal to vf minus vi over t. Then we're going to list out our variables. It's going to be an s, it's going to be an xi, it's going to be a vi, a vf, an a, and a t. So what do I know to begin with? Well, I know that the velocity when the dart hits me on the head is going to be 32 meters per second. That's going to be the end of our motion. So our velocity final is 32 meters per second. And I know that I have a time, which I just changed, of 2.75. Now, let's take a look at what this problem would actually look like so that we can determine what else we know about it. So we have you, this beautiful box, being hit by a Nerf dart coming from the ceiling, straight down. Well, what would that mean about this? That's right, it's a free fall problem. So, what's my acceleration? My acceleration is still going to be due to gravity. So, even though I'm starting with an initial velocity, it's still going to have that same 9.8 meters per second towards the floor. Negative 9.8 meters per second squared. Now I put negative there because what I'm about to do is I'm going to define the floor as 0. That's the only way that this one actually makes sense. Because if I define the ceiling as 0, suddenly I have to do all of my calculations to figure out the height of the ceiling relative to the student's dome, which is 0.75 meters above the floor. I only know this number because I know where the floor is. I don't know it in reference to the ceiling. So my ceiling cannot be my starting point. It cannot be my reference point. The dart does come from the ceiling. That is my starting point. My starting point is some amount above 0, which would be our xi. So in this equation, in this problem, we don't know xi. We know s. We know the ending position of the dart, which is the student's head, 0.75 meters above the floor. So our s is going to be equal to 0.75 meters. Our xi is going to be what we're solving for. Our vi is going to be the other thing we're solving for. And as long as we're at this, we need to set a frame of reference. So let's say everything above 0 is positive, everything below 0 is negative. Everything going down is negative. So that means my acceleration is negative. And what does that mean about my velocity final? Is that going to be positive or negative? Because it's hitting the student from the top. So it's going to be a negative. All right. So let's use our trusty acceleration equation right from the start to find our initial velocity. So it's going to be an a is equal to vf minus vi over t. I need to solve this for vi. So my first step is going to be multiplying both sides by t so that I can get it out from under the bottom. So I'm going to have an at equal to vf minus vi. My next step, I need to get vf over to this side. So I'm going to subtract vf. So minus vf, because it's positive. because the VF is positive VF minus VI, I need to subtract the VF. Another way you could look at this is this right here is the same as saying positive VF plus a negative VI. That all means the same thing. So when we're moving integers around, it's helpful to look at everything as we're adding it together, or we're adding a negative number instead of subtracting a number. So this is going to end up being AT minus VF equals, this is a negative, VI. How do I get this to be positive? Well, it's a little algebra trick. I multiply each term in the equation by a negative 1. Now remember, a term is anything separated by a minus sign, an equal sign, or a plus sign. So I have a 3-term equation here. AT is a term, VF is a term, and VI is a term. So if I multiply each term by the same thing, my equation will still hold true. So everything's being multiplied by negative 1, so all of my signs are just going to flip. So that's going to mean my AT becomes negative, my VF becomes positive, and my VI becomes positive. So VI positive, VF positive, AT negative. Then I rearrange this side, make VF minus AT equals VI. Wow, this is actually a situation where we can look at it and see that it intuitively makes sense. Because my velocity final minus my change in velocity should equal my initial velocity. That's an equation that actually makes sense. Great. So let's plug our numbers in and find our VI. So VF is going to be negative 32 minus a negative 9.8 times a 2.75. All right. That is going to get me a negative 5.05. So my initial velocity, negative 5.05 meters per second. Boxing it off. That makes sense because my initial velocity, I'm shooting straight down. It should be a negative number because it's going in the downwards direction. All right. Now, let's solve for xi. So we're going to set up our s equation, which is the only thing that has an xi. And notice, we have all of the values for VIT 1/2 AT squared. So we're going to be able to combine all of this together. So let's insert our numbers and see how this works. It's going to be VI is a negative 5.05 times 2.75 plus a 1/2 negative 9.8 times 2.75 squared. Okay, so when I say we can combine these, I mean we have all of the numbers. We have all of the values here. So I can multiply these together, I can multiply all these together, then I can add these two terms together. But I have not added anything to xi yet. So I'm still going to have to carry my xi down to the next step. So let's bring all these together first. That's going to get me a negative 50.94. It's going to be xi plus that equal to 0.75. Does everyone see that? So I still carry this down because I haven't done anything with it yet. So in order to solve for xi, I need to get it by itself, so I need to add this negative 50.94 to both sides. So plus 50.94. And that's going to be a 51.69 meters. Beautiful. Box it off. And there you have it.